Alright, brief discussion about unit vectors. So, when we have a Cartesian coordinate system, we will traditionally split things up into vectors that are along the x direction and vectors that are along the y direction. And we can write down something called a unit vector. A unit vector is a vector that has a length of exactly 1. So I hat has a magnitude of 1, and it is along the positive x direction. And the j hat vector, because it is a unit vector, has a length or magnitude of 1, and it is along the positive y direction. Technically, we can also have something k hat, which is also, of course, magnitude 1, and along the positive z direction. Alright, so if we have some arbitrary vector, we can decompose it into these unit vectors in Cartesian notation. It may be interesting for you to know that there is in fact a set of these unit vectors for any coordinate system you choose to use. In polar coordinates, it looks sort of interesting because, of course, polar coordinates have to do with direction and how far out you're going. So you get an r hat vector, which would just be going out along radial direction with length or magnitude of 1. And then it gets more interesting because there is a theta hat vector, which is along the rotation, going counterclockwise, also with length 1. Exactly what the theta hat looks like kind of changes based on how close in you are, how far out you are. And that makes it a bit more interesting to try to write it down, especially in terms of Cartesian components, which is the reason we don't do it here. You'll actually get into that a bit in your Calculus 3 class, where you're talking about vector calculus and different coordinate systems like spherical, cylindrical, and so on. So I will leave that entirely up to them. We just want to get down to a bit of business with what we can do with these vectors. So here's what you can do. Let's say we have some vector A, and we're told that it has a magnitude of 5 and a direction that is 30 degrees, which means relative to horizontal, this angle would be 30, and it has a length of r. We can decompose this into unit vectors. We're essentially going to think about how far is it along the horizontal side and how far is it along the vertical side. And I just realized I was using yellow for one of those before. Let me change the colors really quickly here. I'll take the A vector and I'll try not to hit that spot too much. There. Got through the rest of it without disaster. Alright. And we'll get the y component. And it's basically the same thing as decomposing a triangle. So it's pretty straightforward to do. So basically what you'll find is vector A can be represented as x units in the I hat plus y units in the j hat, potentially plus some number of units in the k hat. We really mostly stick to two-dimensional stuff here, so we don't have to worry about that at the moment. As a matter of fact, it gets kind of painful to deal with because if we're really thinking about full spherical coordinates, we'd have to have a distance and two different angles to describe it. Think about how you need latitude and longitude to define a position on the surface of the Earth, and altitude. So between latitude, longitude, and the altitude above or below sea level, you can fully specify a location on the surface of Earth. We're just going to deal with this like it's a two-dimensional projection, because honestly, most of our problems can be broken down to 2 dimensions. All right, so specifically in this case, we can write that vector A would be 5 times cosine 30 degrees in the I hat, and it would be 5 times sine of 30 degrees in the j hat. So that will let us write it in component form. Of course, the benefit of that is, you'll see in a later section, that we can just add and subtract them in component form like this, I hat, j hat, k hat, very directly. We don't have to do clever drawings to make it work. All right, but I think that's going to be it for this section on unit vectors and components of vectors. We'll talk next about converting vectors to one format and back, although I admit I just showed you how to convert it going one way. But we do need to convert it going both ways, and this will be the reason why we reviewed polar versus Cartesian coordinates before starting.